Now this illustration is illustrating the golden rule when it comes to determining the ampacity of a conductor based upon the conditions of use of such conductors. Now, applying both derating factors in accordance with Table 310.15C1, which is adjustment factors, and the correction factors in accordance with our tables 310.15B1 or B2. Now, notice the information given in the illustration. Notice that the informational note 1 lists these items. So let's look at informational note 1, item 1, which is below the service equipment next to the grounding electrode conductor. We're routing through an ambient temperature of 100 degrees Fahrenheit. We have to apply 310.14A3 informational note 1, item 1, and 310.14A as an apple 2 exception because we exceeded the 10-foot or 10% rule. So keep that in mind. We're routing through an ambient temperature of 100 degrees Fahrenheit that we have to use. Now, item number 2 is to the right top hand side of the illustration. And we're taking a 14.4 amp connected load, increasing it by 125% to get 18 amp connected load. And the sections that tell us to do this or require us to do this is 310.14A3 as in apple, and informational note 1 and item 2 calculating the load, and since it's a branch circuit, we're using 210.19A1. If it was a feeder circuit, then we would use 215.2A1A. But we're just calculating the load there at the 125% rule. Now we're ready to pick up informational note 3 and item note 3. And notice 310.14A3, informational note 1, item 3, and 110.14C1 is applied here. And actually it would be C1A in the illustration, 110.14C1A. All terminals are 75 degrees C, meaning the 75-degree column can be used as long as we have it, our conductors in a conduit system or cables that would have a 75 degree C rating. Now, we're ready to use the final item number 4 that's listed to the left pointing to the conduit. We have 8 conductors in that raceway that are classified current carrying per table 310.15C1 as well as 310.14A3 informational note 1 item number 4. We have to pick up a 80% D rate or 70% D rate. And based upon 4 to 6, it'd be 80, but we're over 6 up to 9, so we have a 70% D rate. So now let's go to the table, or not the table, but the boxed in information, and apply what we have just gone over. Step 1, table 310.16, list a number 12 AWG THHN is 30 amps. Now, some engineers would still use the 75-degree column, and that's okay if they want to do that, but they don't have to. They could use the THHN 90-degree column for that number 12 of 30 amps. In step 2, table 310.15C1, 8 conductors is 70% derated adjustment factor we had to collect. Adjust those factors. Now, note 3, we're applying correction factors, 310.15b1, based upon the 100 degrees of Fahrenheit in the 90-degree column of that table, we pick up 91%. And step 4 is the application of the adjustment and correction factors of 71% and 91% times the 30 amps in step 1. We come up with 19 amps. Now evaluation time has to take place. Table 310.16, as well as 240.4D, says a number 12 conductor has to be protected by 20 amp unless the load is one of those loads in table 240.4G. So we would say, okay, as designers and installers, does the 19 amps supply the 18 amp calculated load? Yes, it does. What size is the overcurrent device above 18 amps? 20. What's the size overcurrent device above 19 amps? 20. So the solution and the answer, 240.4D and table 310.16, requires a 20 amp device and number 12 20 amp conductors, and this calculation, applying the golden rule of items 1 through 4, have been met, and this installation complies. And this is what figure 8-15A is showing. And in closing out this illustration, I would like to point out once again that engineers and electricians use this as a golden rule when they use 310.14A3, informational note 1, items 1 through 4.